we are talking about transforming the data. So transformation is done when your data is skewed towards one side. So you want to neutralize those outliers or extreme values in your data so that your modeling process is not disturbed. You can use any modeling process you want. So there are many ways to transform your data. There are L1, L2 regularization techniques, normalization, standardization, and many others as well. But these are some of the most commonly used or most commonly cited techniques. One is normalization. Okay, what is normalization? Normalization actually it is being used in many fields of sciences, physics, chemistry, or many other things. If you look at the general idea of normalization, uh, you might have heard about normality. What is normality? Normality is to make the solution, or I guess it is related to pH, to a certain point that it is uh, close to some value, if I remember. So I guess maybe neutral pH or whatever. So it is just like that. Normalization is a technique. It is where you actually want to sum up all of your values between 0 and 1. It is also called as min-max scaling. Um, so it is the general formula is presented here. X is the value you want to transform. X minimum is the minimum of among all values, and X maximum is the maximum among all values. So we can also execute this in a very quick way. For example, let's assume that we have some data. So this is the data I have. Now you want to normalize. You can already see that there are certain values which are way above general range, or if we look at the mean. So mean here will be, this is your mean. And if you look at the standard deviation, so this is a standard deviation right now. Got it? So let's transform this according to normalization. Okay. So what was the formula? That first you want to input the original value, which is it right now is in B2. You would want to subtract the minimum. So what is the minimum here? 2. So I will just hard code it. For example, 2. Okay. Divided by maximum. What is the maximum? So what you see here, the value which was minimum is at 0. Now it is transformed to 0. And value which was maximum is transformed to 1. And if you look at the mean right now, the mean has changed. Previously it was 0.45. Now it is 51.5. Similarly, if we look at the standard deviation, it is now only 0.31. Now this can be easily influenced by the data itself. For example, if I change it to 32, so that means my minimum here is now 23. And this will change my mean, which is 0.37, and also it will also impact my standard deviation. So this was these are normalized value. We have arranged all our values between 0 and 1. So what is the idea here? Idea is very simple, that when you are dealing with the data, suppose you have a salary column, you have an age column, you have a CGPA column. Now the range of values in salary is in thousands. And when those values will go into your modeling process, for example, a linear regression or logistic regression or some other method, when you will multiply your age or CGPA with salary or something else, so the calculation will utilize your maximum memory, your maximum CPUs. So the computing time will increase when you have larger values to multiply. That's very simple. So, but when the values are normalized, that means they are only based between 0 and 1, whether it is salary, whether it is your age, or whether it is your CGPA. They're all transformed between 0 and 1. So that means the computing time will be saved. When you are going to correlate or regression, you will perform regression. In regression, we always try to correlate or make relationship between two or more variables. So when you are trying to achieve that goal, so that calculation, the normalized value will require much less computing power and time. So this is the main idea here between the and also it kind of neutralizes or the impact of or minimizes the impact of outlier as well. So if I just look at, if I say okay, now maximum value is 1112. If we just look at change this thing here, still very little impact, but there is impact obviously. The mean has changed from 0.37 to 0.18 because this value is much greater than all other values. But normalization is a very good technique when you are dealing with huge number of values. Okay. Next thing is standardization. Standardization is also a data transformation technique where you actually uh, you want to uh, bring your mean to 0 and your standard deviation to 1. Whatever your mean is, you want to bring your mean to 0 or close to 0, and your standard deviation should be 1, plus minus 1. So this is called as standardization technique. Idea here is very simple: the value and minus the mean divided by standard deviation. So this is the formula here, and if we just look at this formula and try to execute here, okay. So let's try standardization. Okay, value is in B2 minus, what is the mean? 56.5 divided by, let's say your standard deviation is 29. So that's how it is transformed. If you look at this data, most of your data um, is 0 plus and minus 1, around that range actually. So what is the mean here? 0. What was the mean here? 56.5. So that's a huge transformation actually. So you can see the impact of data transformations on all of these actually. So standardization is a very good technique when you don't want to scale down the values. In fact, you want to scale down the distribution itself. Actually, we are dealing standardization is where you want to play with the distribution. You want to alter the distribution of the data instead of having very high means or very high standard deviation. You want to say that okay, I will have zero mean and I will have unit change in standard deviation. So that is the idea here. So that means the some of the major differences. Okay, the very good question here that when you should use normalization and when you should use standardization. So normalization is done when your data does not have normal distribution. That means it has some skewness in the data. Normalization is done when your or normally statistical people says that it does not have Gaussian distribution. So when there is no Gaussian distribution, you go for normalization. You normalize in a certain range of 0 and 1. But when your data is already in Gaussian distribution or normal distribution, that means it has a kind of zero skewness. It has a nice, beautiful curve on both sides. So you go for standardization. So only want to take, we only want to scale down the, you can say, distribution of the data rather than the whole data itself. Okay, these are some of the key differences. Normalization, in normalization, you take into account minimum and maximum values, and for standardization, you always take into account mean and standard deviation. And then it is used when features are of different scales, like I have given example of salary and age and this and that. And standardization is used when you want to make sure that your mean is 0. So we don't want very high means actually. So that means you want to make scale down your distribution itself. So this is a range actually. It is not bounded by range. It is bounded by 0 and 1. When the presence of outliers, when outliers are there, so because normalization is normally done on the basis of mean, not median. So that means it is most affected by the presence of outlier. But in case of standardization, sorry, I said other way around. Normalization is affected most by the presence of outlier because we are taking into account the minimum and maximum value. If the maximum is very high or minimum is very low, that means it is a chance, high chance that it is an outlier, and the whole process will be disturbed because of those outliers. Standardization is dependent on mean, so it will be affected by the presence of outlier, but not to that scale, not to that degree as the process of normalization, because normalization is actually taking into account the minimum and maximum values, while standardization is only taking around the mean and standard deviation. So this, so both of these processes will be affected, but normalization will be affected more. In Python scikit-learn, you will find these functions min, max, scalar, and standard scalar for these two purposes. And uh, also about the distribution, we don't know about the distribution of data, so we go for the normalization. And we have, if we know about the distribution, we go for standardization. And other names are this normalization is also called min max scaling, scaling normalization, and standardization is also called z-score scaling normalization as well. So these are the key differences between